Okay, this is the Chapter 6 test review. I'm going to take some time now and go through each of the problems on the review packet. And the hope is that you'll watch and study for your test so that you can pass it. Alright, taking a look at the packet, the first three problems ask you to solve a linear system or a system of linear equations using the three different methods that we've learned in class. So the first problem asks you to solve by graphing. Because it asks you to solve by graphing, the expectation is that you solve it by graphing and not use any other method. So, taking a look at the first equation, most of you like to have that written as y equals mx plus b. So I'm going to solve this first equation for y by subtracting x from both sides. And when I do that, I get negative x plus 3. To graph an equation like y equals negative x plus 3, you start at the beginning point, also known as the y-intercept, that's 3, and then you move according to the slope. And in this equation, the slope is negative 1, or as a fraction, negative 1 over 1. So I'm going to put points on the graph and graph it according to this equation. I start at the beginning point on the y-axis at 3, and then I move negative 1, which is down 1, and forward 1. Remember, when you're graphing a system of equations, you want to put as many points as possible so that you can be accurate in finding the point where they cross. So I'm going to keep going. Down 1, over 1, down 1, over 1. And then you draw your line through the... To graph the second equation, same process. Start at the beginning point. The beginning point for this equation is negative 1, and the slope is 1/3. So I start at negative 1, that's down 1 on the y-axis, and then I move up 1 over 3. And it only takes one movement to find that these two lines intersect at this point. So the solution to this system of linear equations is the point where they cross, and that point is 3, 0. For the second equation, they're both written in slope-intercept form, so you could graph them the same way you did the first one, but I also showed you how to use your graphing calculator in class. So if you wanted to, you could take out your graphing calculator and enter the equations by hitting the y equals button. And then you enter the first equation, 2x plus 5. Enter the second equation, negative 4x minus 1. And then you graph them. Once the equations are graphed, if you can see where they cross on the screen of the calculator, then the calculator can find the point of intersection for you by simply pressing second, trace. Option 5 is intersect, so second trace 5, and then enter, enter, enter. As you can see at the bottom of the screen, it says negative 1 and 3. Negative 1 and 3 is your solution. Now you still need to give me a graph. So one way to do it would be to look at the calculator, figure out where they cross, and start with that point. They intersect at negative 1, 3. Negative 1, 3 is this point right here. The first equation has a slope of 2, so I could make another point for this equation by starting at the point of intersection and going up 2 over 1. Up 2 over 1. That's the first line. The second equation has a slope of negative 4, so I could go down 4 and over 1. And now I have a pretty good picture of what my two lines look like, same as the calculator. Okay, moving on to the next set of problems. In the next set of problems, you're asked to solve the system of linear equations by substitution. Remember, when you substitute, you figure out what one of the variables equals and then replace that variable in the first equation. So for 2a, y equals 2x minus 11. So I'm going to put 2x minus 11 in place of y in the first equation. So I get negative x plus 2x minus 11 equals negative 4. And now I have one equation with one variable. I can solve for that variable. In this case it's x. Negative x plus 2x is x. Keep going, add 11 to both sides. X equals 7. I have half my solution. Now that I know what x is, I can put that value of x back into the equation that says y equals 2 times x minus 11. 2 times 7 is 14, minus 11 is 3. The y equals 3, there's the other half of my solution. Okay, the second example of a substitution, the system is written a lot like a graphing system would be written, but you have to use substitution. So I take what y equals, and I put it in the first equation in place of y. So by replacing y with x plus 3, I get a new equation that says x plus 3 equals 3x plus 5. Now this is a problem where you're asked to choose a variable side and a number side and solve for x. So I've chosen the right-hand side to be the variable side just because 3x is bigger than 1x. But if you do it the opposite way, it's not wrong. You'll still get the same answer. So start by subtracting x from both sides. I get 3 equals 3x minus 1x is 2x. And now I subtract 5 from both sides. 2x equals negative 2. So divide both sides by 2, I get x equals negative 1. There is half of my solution. I know what x is, and now I can figure out what y is by putting the value of x back into the equation that says y equals negative 1 plus 3. Negative 1 plus 3 is 2. So y equals 2. There's my solution. Alright, turn the page. The last method for solving a system of linear equations is the elimination method. So looking at the first example, I have two equations. I'm just going to pick the x's or the y's and figure out which one I want to eliminate. Well, for me, in this problem, it would be easier to eliminate the x's because all I need to do is multiply the bottom equation by negative 2. So if I multiply the bottom equation by negative 2, I get negative 2x, that's that. Negative 8y, that's negative 2 times 4y. And negative 14, negative 2 times 7. So I've transformed this second equation into my new equation, and now I'm just going to add 2x minus 2x. Those eliminate. Negative 3y and negative 8y makes negative 11y. Negative 8 and negative 14 gives me negative 22. And I solve for y by dividing by negative 11 and get y equals 2. That's half of my solution. I just figured out what y is, so I have to make sure I put that in the right spot in my ordered pair that goes there. Now to figure out what x is, I can put the value of y back into any of the equations that I have. I'm going to put it back in this equation, just because it looks like it's easier. So I put the value 2 in place of y and get x plus 4 times 2 equals 7. 4 times 2 is 8. I subtract 8 from both sides and I get x equals negative 1. That's the other half of my solution. The second equation, the second example of using the elimination method, is all ready for you to eliminate because the y-coordinates are already exact opposites. So I just have to add the two equations together. Those eliminate. 3x plus 2x is 5x. 31 and negative 6 makes 25. So x equals 5. That's half my solution. Now to figure out what y is, I can pick either of the two equations and replace the letter x with 5 and solve for y. So I'm going to choose the top equation. 3 times, replace the letter x with 5, plus 4y equals 31. 3 times 5 is 15. Subtract 15 from both sides, and I get 4y equals 16, so y equals 4. Divide both sides by 4. Okay, those are the three different methods used to solve a system of linear equations. In the next three problems, you're asked to figure out if the system has one solution, infinitely many solutions, or no solutions. And you can take the time to go through and actually solve the system, but the goal is that you're able to look at these equations and just work through it logically. So, you should know that a system that has one solution is one where the two lines intersect and give you one solution. And you should know that a linear system that has no solutions is one where the two lines are actually parallel, so they never cross, so there's no solution. And finally, you should know that a system that has infinitely many solutions is one where you're just graphing the same exact line twice. The two lines are identical. So knowing that, if you take a look at the first example of this section, problem number 4, what you should notice is these two equations have the same slope and a different y-intercept. Two equations that have the same slope and a different y-intercept make parallel lines. Therefore, the answer to number 4 is no solution. They'll never cross. Taking a look at problem number 5, if you multiply the top equation by 2, 2x times 2 is 4x, and 2 times minus 4y is minus 8y, and 2 times negative 8 is negative 16. This top equation is identical to the second equation. They're two identical equations. That means when you graph them, they make the same exact line. That gives you an infinitely many solutions. And finally, in number 6, if you look at the two slopes, they're different. They have different y-intercepts. That means when you graph them, they will cross, giving you one solution. Again, you could take the time to go through and solve each of these systems, but it's much quicker if you just work through it logically. Okay, the last page is the set of story problems. Each of these story problems, I won't read them to you, but each of them gives you an equation, and the equations will be written in ax plus by equals c. And you should be able to identify a problem that's written in this form because it just gives you two different objects and then a total. For example, senior high school, try a different color. The senior high class at A rented and filled 8 vans and 8 buses. In an equation that looks like this: 8 vans and 8 buses for a total of 240 students. High school B does the same thing. They rent 4 vans and 1 bus for a total of 54 students. This is a good problem that you can solve using elimination. You can do it a variety of ways, but I think I'm going to multiply the second equation by -2 and eliminate the x variable. Doing that gives me -8x, -2y, and -108. And now I add everything together. The x's eliminate. 8y and -2y gives me 6y equals 132. Divide both sides by 6, and I get y equals 22. Now the y in this case is just the second variable, so the second variable is buses. That means there were 22 students in each bus. And now I take that value of y, which is 22, and I can put it into this equation. 4x plus 1 times 22 equals 54. Subtract 22 from both sides. I get 4x equals 32. Divide by 8. X equals, divide by 4. X equals 8. 8 students in each van, 22 in each bus. All right, number 8. It's very similar. Matt and Ming are selling fruit. Customers can buy small boxes and large boxes. Matt sold 3 small boxes and 14 large boxes for a total of $203. It's just a standard form equation. 3x, 3 times small boxes, plus 14y, 14 times large boxes, equals 203. Ming sold small boxes and large boxes. That's 11x plus 11y, and that's a total of 220. It's the same type of linear system. You're going to solve using elimination. You could solve using substitution, but that looks like it would be a lot more complicated, and graphing would for sure be way more difficult. So looking at these two equations, probably the best way to solve this would be to get rid of the x coordinate and find a common multiple between 3 and 11, which would be 33. So I'm going to multiply the top equation by 11. 11 times 3 is 33. Multiply the bottom equation by -3 to get -33x on the bottom. My new equation for the first equation would be 33x plus 154y (11 times 3 and 11 times 14), and then 11 times 203 is 2,233. Multiply the bottom by -3, I get -33x minus 33y equals -660. And now I'm all set to eliminate. The x's go away. 154 minus 33 is 121. Y equals 2,233 minus 660 is 1,573. Divide both sides by 121, and you get y equals 13. Y in this problem is the second variable, It's the second set of boxes sold, which is the large boxes. So a large box costs $13. And notice that down here in the answer, they're backwards. So be careful that you put the number in the right spot. Once you figure out the number of large boxes, you can plug this variable back into either of this equation. I'm going to take a shortcut and just tell you the answer is 7. And because this video is getting very long, I'm going to look at number 9 and show you how to set the equation up and then give you the answers. That way you can do the elimination method on your own. Number 9, similar problem to number 7. High school A rented and filled 1 van, 6 buses, 372 students. That would be 1x plus 6y equals 372. High school B filled 4 vans, 4x plus 12 buses, 12y equals 780. Okay, really quick, you could multiply the top equation by -4 and then use that to eliminate. When you're all done, the answer is 18 students in each van, 59 students in each bus. Alright, hopefully that's going to help you study for the test. I would suggest that you get on Schoology and print another copy and try it again all by yourself, start to finish, if you struggled on any of the problems. That way you can practice doing it the correct way. But as usual, if you have any issues, come talk to me in class and I will help you and show you some more examples.